Okay, this is Henderson Secondary Physics Prelim 2014 paper. It is quite a standard O-level paper, and you should aim to get at least 75% from it. So let's start with paper 1. Paper 1 is quite straightforward with a good mix of simple and difficult questions. So let's begin. Okay, question 1 is your vernier caliper. The only variance here is that on the main scale it is given in mm, so you have to first do a conversion to cm first to avoid any careless mistake. So from here, this 30 is actually your 3 cm. Okay, the interval is the same as a regular vernier caliper. So on the main scale, basically you read from here where the 0 of the vernier scale stop at. So it stops at here. So meaning that on the main scale, you should read to this interval. So this is 30, 31, 32, 33 mm. So 33 mm is your 3.3 cm. Then after that, you go to your vernier scale. You see that the scale align at this point. So this is your 0.05 cm on your vernier scale. So you add these two up, you get 3.35, which will give you the answer B. Okay, for question 2, it is your standard pendulum swing question. The variance here is that they are taking the number of times the bulb pass through Y. So if you start counting your oscillation at Y, you will notice that it will go this way for one complete oscillation. It will go right, so a quarter, 2 quarter, 3 quarter, 1 whole. So to complete one oscillation, basically the bulb will pass through Y 1 time, 2 times. So I repeat, let's say I start at here. It goes here 1 time, 2 times. So one oscillation, the bulb will actually pass through Y 2 times. So meaning that if you count for 21 times, that means the bulb would have completed 10 oscillation. You have to divide by 2. So why this 21st time? Because the first time is when you first start counting. So the first time you don't consider that that count part of the oscillation. So it's like 1, 2, 3. So you see, even for one oscillation, the bulb will pass through point Y 3 times, because the first time that count is the signal to start the timer. So that's why even for 21st time, actually you can consider it as 20 times, because the first time is when you first start timing. Okay, and one oscillation, the bulb will pass through Y 2 times, so that's why 20 divided by 2, you get 10, and you take the total time divided by 10. Okay, question 3 for average speed. Okay, for average speed, you need to find the total distance, which is your area under the graph. Then after that, you divide by the total time, and you will get the answer. Okay, for question 4, note that it is a rough surface. So rough surface is an indication to you that there is friction. So meaning that when you are considering the net force actually make up of 2 components, the pushing force and the friction. Okay, so you need to get this part straight. And you also know that because now the pushing force is towards the left, your acceleration will also be towards the left. Okay, so after you do this, substitute the right value, then you do your algebra, you will get the frictional force. Okay, why is it that now that you find the frictional force is 3 Newton, why is it that the pushing force needs to be 3 Newton as well? Because if you want to have a situation whereby you have a constant speed means that your net force must be 0, right? Because acceleration is 0. So since even though it is at constant speed, your net force is still consisting of two components. You will have your new pushing force and you will have the friction. Now, because friction is only dependent on the weight of the object and the surface condition, the weight does not change, so your friction will be still the same as this value. So what happens is that because now your net force is 0, so meaning that your new pushing force must be the same as your net force. Your new pushing force must be the same as your frictional force. So that's why it is still 3 Newton. Okay? So just by finding out the frictional force, you can actually answer what the new pushing force must be. Okay, your question 5. Your question 5 is a variation of whether or not you can interpret a VT graph just by acceleration. So what is the trick here is that you see here, there is a resultant force, meaning that, and your resultant force is constant. And resultant force is equals to ma, right? Because F net is equals to ma. So if your resultant force is constant, it means that your acceleration is also constant. And because your resultant force is positive, your acceleration must also be positive. And similarly for here, okay, you see that now the resultant force is 0. So meaning that your acceleration is 0. And if acceleration is 0 means that your velocity is constant. And the last part here, your resultant force is now negative, but it is constant. So your A will be your negative constant. Now if we translate this observation into your VT graph, in your VT graph, your acceleration is your gradient. So meaning that the first part of the graph here, okay, in a VT graph, the gradient need to be a positive constant. So you see in your option A, this is a positive constant. So we can consider this. B, you see that your velocity is constant, but your gradient is flat. Means that there is no acceleration, and it actually contradicts with this information, right? So you know that B is a no-no. If you look at C, okay, C, you see that yes, the gradient is constant, but it is negative. So again, it contradicts with this information. So you know that C is a no-no. Okay, so now if you look at D, okay, D, yes, the gradient is positive, is constant. So okay, D is still in consideration. So we look at the next information. Acceleration is 0, V is constant. So here, V is constant. So okay, I can accept this. Look at D. D again is constant, so I accept it. Third information, the acceleration, that means the gradient must be constant, but it's negative. So A, gradient is constant and it's negative, so A is correct. If you look at D, okay, gradient is constant, but it is positive, which contradicts with this information. So you know that D is not possible. So it confirms that A is your answer. Okay, question 6 is similar to your Temasek prelim paper, the density question. And in Henderson's paper, actually it gives you diagram to help you visualize the experiment, so it is easier in a sense. So what you need to do is that you need to first determine the mass of the sand, which you can get by having 1002 minus of 308, the mass of the beaker. Then after that, you can find out that, okay, at this water level, what is the volume of the beaker? So using the density and the mass of the water, you can find out that, okay, at this water level, my volume is 500 cm cube. Then from here, what you can do is that you can take this 1005 minus off the mass of the sand plus the beaker. So down here, this 1002 is the mass of the sand plus the beaker, right? So if you take this value and you minus off this, you can find out the mass of the water here. So once you find out the mass of the water here, you can then find out the volume of the water here. So once you get the volume of water here, you can take this volume minus off this volume to find you the volume of the sand, which is 200 cm cube. So how I get this value is that I just take this 500 minus off this 300, you get this 200. So once you reach this step, your density can be calculated from these two values easily. Okay, mass over volume, you will get the answer D. Okay, question 7 is very interesting, I find. It is kind of like a moment question. Now, they didn't tell you exactly how many forces are acting here. They didn't tell you where is the pivot. So if you try to estimate, saying that, okay, there must be a center of gravity here, that there can be a weight of the bridge, and then your human being is walking on it, you will realize that there will be too many unknown for you. So you cannot directly use your principle of moment and then try to find what is the weight here, what is the mass of the man here, and all that. It will be too complicated. So what you know is that the bridge start to crack when the 100 kg man walk to 10 meter. So what this statement is telling you is that because it is about to crack, meaning that the moment is at the brim of being unbalanced. So meaning that the moment from the man, the moment from Simon, I call it big S, which is equals to, I have written here, which is equals to 1000 multiplied by 10, is actually the limit, the breaking limit for the bridge in terms of moment. So you know that the bridge can only support a moment of 10,000 Newton meter. So with this understanding, you can then calculate what is the weight of the smaller man, Darren. So this 10,000. This 10,000 is the breaking limit. Okay. So why do I have it here? 1, 2, 3, 4. I have written one more zero here. So what happens is that you take the breaking limit, okay, and equate to the moment caused by Darren, which is weight of Darren times 20 meter. So with this, you can then find out what is your mass of Darren, which is 50 kg. Okay, so this one actually represents the breaking limit for the bridge, and you equate to the moment caused by Darren. Okay, and you can simplify the problem. Okay, you need not find where's the pivot and what is the weight of the bridge, things like that. Okay, question 6 is quite standard. So this one I don't think I need to explain it in the video. If you are having difficulty, do come and look for me in the office. Okay. Yes, you can find this experiment in your book. I think it's in the chapter where they are explaining center of gravity. Okay, there's a section in the book that explains to you how the experiment is done and why certain steps are being done. What are they trying to find out? So read on that and try to understand from there. Okay, question 9 is about your liquid pressure. So what happened is that this tube is slanted. So when you are using the formula P equals to rho GH, okay, the H must be the vertical height. So how to find this vertical height? Just use your Tokaso, your trigonometry. You will find that this height is given by 80 multiplied by sine 70 degree. Then just use your P equals to rho GH. You will be able to find the answer here, the atmospheric pressure. Okay, this one is question 10 is quite tricky. Now what happened is that the pressure is given in mm mercury, but the liquid in the tube is actually your water. So you can see, okay, this statement indicate that the liquid here is water. So what do you need to pay attention is that this is for mercury, but you are using water. So you need to convert this mercury thing into mm water. Okay, so what happens is that now your right hand side is reduced by 6 mm Hg. So if this side's pressure is being reduced, so what happens is that the water level here will increase and the water level here will decrease until the pressure on both sides is equalized. So what you need to do is first you must find out that this 6 mm mercury is equals to how many mm water. So if you do that, you just put rho GH here, but this rho is the density of mercury. This is the density of the water. So just put in the right value and you will find that, okay, the 6 mm mercury actually correspond to 81.6 mm of water. Now I also make a mistake here and I thought that, okay, I have found the answer. The thing will decrease by 82 mm. But please take note, this is a U-shaped column. So this 81.6 mm height is not going to suddenly disappear from the left hand side. Okay, what happened here is that this 81.6 mm, the difference will be the left hand side will drop and the right hand side will increase by an equal amount. Okay, so what happened is that you need to take this 81.6 and divide by 2, because what happened is that this 81.6 mm difference in height is going to be shared by the left hand and the right hand column, and because this guy is moving down, this guy is moving up, so actually the effective height difference will be divided by 2. So that's why your answer is C instead of D. So that's why I find this question very interesting. Okay.